Welcome to the Solid Edge Mold Tooling demo. We're going to start by opening this assembly and adding a plastic part. So on the Mold Tooling toolbar, we're going to import our plastic part. In this case, it's a belt cover. Inside the interface, you can see that we can control the parting line, have it automatically created, or do it ourselves. We also can control the shrinkage factor, whether it's uniform or individually shrinking in different directions. We also want to make sure that our injection and ejection sides are correct. We can select a face, and you can see that it will reorient normal to the base coordinate system. But you can see that we have different colors inside, which means that we have faces sorted to the wrong side, injection faces on the ejection side. We can tell that using these colors if we go and we look at the settings, what these colors actually mean. In the UI here, you can see that we have negative faces and positive faces, which again is the injection and ejection side of the mold. And a blue face means it's crossing over from one to the other, which isn't good in the middle of a part. So what we want to do here is actually we're going to reset this back to the original orientation when we brought that part in. And then if we turn that back on, you can see now we have all red faces and all yellow faces, meaning that we don't have any backdrafts in our part other than in those holes, which we'll take care of by designing a slide face. So to design the slide face, because we know we're going to need that slide to create holes in our part, we're going to create a new part in place, building in the context of the assembly to make sure that it matches up with our part. So how we do that is we'll just go to the Home tab, and we have the Create in Place command. And here we're just going to define this as the slide face, and we're going to go ahead and create and edit this part. Now we're going to be using the part itself as part of the design, so we're going to create an inner part copy of this plastic part into this new slide face part as construction geometry, and we're just going to get the entire body. The end of the slide is going to be defined by the inside face of the part, so we're going to copy that surface and we're going to fill in those holes by removing the interior boundaries of our surface. And that's just an option that we have in Solid Edge. Next, we're actually going to start building the design. So we're going to start by actually creating a protrusion or an extrusion, and we can get that from our radial menu, and we're going to offset from the origin 100 millimeters. So we're just going to create a parallel plane to the YZ plane out 100 millimeters, and then we're going to include the bottom edge because the slide is going to come right up to the bottom edge of that surface that we copied. So we'll include that. And then we can just use Solid Edge's sketching tools to define what this slide is going to look like. Now we want to have angle on the sides of the slide because again this is going to have to shut off from the top to the bottom so that it seals around that slide, and it's a whole lot easier to seal on an angle. We use some smart dimensions to offset from the holes 4 millimeters in all directions. And then finally what we want to do is add the angle to the sides so that they're the same. We'll make that a 5-degree angle, so we'll just put 95 in here on both sides. So once we're done with that, again this is an extrusion, and the options that we have are at a finite distance, but in this case we're going to go from to. We're going to go from the sketch plane where we just sketched this up to that copied surface, and you can see that it will match that contoured surface of the inside of the part, which is exactly what we want. It has to seal on the core that's going to be inside the middle of that part, making that void. And then of course this is going to make holes, so we actually want to boolean away the plastic part, the construction part, from the slide so that we get the holes on the end of the slide, or the protrusions on the end of the slide to make the holes. And we'll add some rounding. We don't want sharp corners inside of our mold, so we'll add some rounds to the top edge. And then the last thing that we want to do is create a center plane And this is going to help us later when we actually want to attach this to the slide body that I showed you during the setup. So we're going to just copy that parallel surface to the midpoint of the back edge of the slide here, and that's going to be, again, this is going to be our center plane. Once we're done with that, we need to tell SEMoldTooling that this is in fact going to be the slide part. So let me hide the construction geometry here first, and then we're going to come up to the SEMoldTooling command ribbon, and one of the next step in the process is to define any slides. So simply select that part, and it gets added to the plastic tool part. So now that we have a slide, the next thing we need to do is define the parting line. And we're going to define the parting line actually manually. Remember, we turned off that automatic split when we added the part. So as one of the steps here is to manually define the loop. And so that puts us in the tool part, and we'll turn the part over here because we're going to go right along the bottom edge. Now we could have done this automatically, it would have worked, but I want to show you the manual method. And you can see it will chain until it hits a corner where it's not a continuous loop. We'll just continue to walk around that part, and once you have a complete loop, you can see that it turns green, indicating that you're done. Now we also have an inside loop because we're going to have a hole in the middle of the part here, so I'll define the inside loop as well. And once we're done with that, we'll click preview. And you can see that white edge, which is our parting line. You also see that we have two different colors. You have the injection and ejection side. You should have one injection loop and one ejection loop. So if there's multiple numbers there, then you know you have a problem. So far we're in good shape. The next thing then that we want to define is the actual parting surface from that loop. And so we simply select the parting surface command and select our part. And then what we want to do is actually define how each one of these parting surfaces are going to be created. So for any interior loops, we're going to use the patch filling type. That's the simplest form of filling that we have. And then for the outside loop, let's set this to loft. And I just want to show you the difference between some of these. And it's always going to tell you that you got to rebuild the parting surface when you make any change to it. So you can see we have this parting surface. It's not exactly ideal. First thing is you can see that we have a nice rounded edge on the part, but as it extends out to the, as it radiates out, you can see that we get this cusp, that it's not nice smooth curve, because basically it takes the center of that curve and creates a point and then creates a curve through the 3 points, which is not, it would be very difficult to machine. So when you have rounded parts like this, it's best to use sweep, where we take that vector that's at the end point and sweep it along that curve so that we get a nice smooth continuous surface all the way out to the edge of the parting surface. Next issue I see is that I have a twist in the part, that I'm going from a vector that's straight down to a vector that's going to the right and moving up the part, so it's kind of rotating as it goes up, which is not ideal. So how we fix that is by adding an extra vector at the point along the parting surface, and then you define the angle for those points. So the first vector is going to be pointing straight down, so you'll have that nice continuous loop up to that point, and then it will radiate in a planar fashion, and the second point will be going to the right, or at 0 degrees. Same thing down here at the bottom. You want to make this a very nice machinable surface. You can select multiple points and define all of their angles at the same time, all the vectors. So in this case I want those all to be at 180. And you can see that those vectors will all align with each other, which will make a nice smooth surface. Now you see we have a gap here, and that's because you can't have two vectors directly lying on top of each other. So when you have a case like this where you have a point up at the front of the slide and at the back of the slide, they have to be at slightly different angles. So we need to change this back angle by 0.2, which in this case would be again minus 179.8, and that will give us a new vector. And if we preview that, you'll see that that'll fill that gap in, and it'll fix the issue that we have in this area. So as I lay the part down here, you can see we have a nice smooth transition, machinable surfaces all the way around. So now that we have our parting surface defined, the next thing we need to do is define our core cavities, or the what we call the parting zone. So that's the next step in the process here, is we'll add the parting zone from the SEMoldTooling ribbon. And you define that by just clicking the part. And then you need to define whether it's going to be rectangular or round core cavity blocks. In our case, it's rectangular, and you want to define the opening point where we're going to inject plastic into this part, where you want the mold to open. And I just select it by a key point on the part. And then I want to size my core cavity blocks. You can see the check mark there. That means that the core and the cavity block dimensions are going to be the same for X and Y. And I also want it to be the same for Z in this case. I'm going to make it 77 millimeters, and I'll explain why later, why I'm using that dimension. So you can see, get a preview of that, and you can see how it's splitting that into two blocks along our core cavity and along that parting surface. So if we hide our cavity block, you'll see the core, and if I hide the plastic part, you'll see what the inside looks like. Now, I have a little bit of a problem. You can see that center loop that I used, the patch filling, that would be a very ugly thing to machine. It really should match the same contours as the rest of the part. The other thing I don't like is that U shape, and we want to get rid of that. So I'm going to edit the definition of the parting surface, and what I'm going to do is add a new loop. So as part of the definition here, there's an option here to add a new loop, and I'm going to do it by vertices. I'm just going to click two vertices to define a new interior loop, and once I accept that, it'll create a vector between those two, and then it will automatically show you that inside loop in green, and that's the new loop that I want to create. And before I regenerate, like I said, I want to fill in that patch area as well. I don't like that. So first of all, let's see what that preview looks like. There you go. You can see now we've got rid of that U shape, which is a lot better, a lot more machinable. And now I'm going to redefine that interior loop where I set it to patch. I'm going to set it to none, because I'm actually going to manually create some surfaces in there that match the inside contour of that part, so it's a very machinable and very smooth transition through that area. So what I'm going to do is actually kind of exit SEMoldTooling to where I'm just in place activated into this parting tool. I'm going to use the go to functionality. This is an ordered part, so you have the order of operations here. And what we're going to do is come in here and copy the surfaces. So I want to copy the surface and remove the exterior boundaries. So when I do that, you can see you get this nice rectangular surface, or in this case the torus type surface. Basically, I copied those three surfaces and extended their boundaries so that I can come back and trim those together to make that interior face and have it match perfectly the inside of the part. So I just need to trim these surfaces against each other to make sure that they're all trimmed up nicely in that area. Once I have those trimmed, those two surfaces trimmed, I also want to trim to the boundary of the loop. So again, this is going to be, remember, defining the surface. That's the surface for that loop. So again, I'll trim to the boundary, and then for the torus area here, I'll also trim that to the boundaries, provided the edge of the surface and also the two lines, the two curves. And once I have those three surfaces, I'll stitch them together into one surface that I can use to define the parting surface for that loop. And I can do that just by going back to the parting surface command in SEMoldTooling, and again redefining that loop, and this time instead of patch I'm going to use selection. And the option on the ribbon here is to define the patch, which I'm going to define as that stitched surface. And we'll preview and finish that, and you'll see on the core side of the mold now it'll be nice and smooth. We'll match that contour exactly, very machinable. Okay, so you have a nice smooth surface. You can see the inserted area where we got rid of that U shape going out the entire part. We could put an insert in there to create that, which again would be much more machinable. Step then is to define this as a 4-cavity mold. So what we want to do is pattern our core cavity set. So I'll go ahead and show you the core and the cavity, and then the next step again in the mold tooling ribbon here is to define that pattern. This is going to be a rectangular pattern. Again, 4 cavities, so I have 2 in the X and 2 in the Y direction. And then I want to define the spacing. And in the X spacing, it's going to be 100 and then 0 in the Y, because I want the cavities right up against each other. And in this case too, I want to include rotating 2 of the cavities, core cavity sets, because of those slides. I have to be able to get the slide in and out. So they'll be 180 degrees off from the original. And then also want to define a runner bar, because I've built in pinch, what we call pinch in the mold, so that when the mold comes together, the plates don't hit. The core and cavity actually is the only thing that hits to make the seal. And there you can see we have our core cavity sets, and we'll just hide the construction geometry. The next thing then is to define the parting zone again. This is going to be the parting zone for the entire mold. And what we want to define here is the opening point. This is what's going to split the runner bar into 2 pieces. So we want to make sure we define the same opening point where we're going to run the injection channel on this mold. And we'll preview what that looks like. And as I said, I used 77 millimeters before to define the height, and that's because of the mold base that we're going to pick. And as I said, I built pinch into this mold, so there's actually going to be a space between the core cavity plates, and you can see now the parting surface, or the parting line, is in between that. So I have a millimeter sticking out of each side of the mold. Next thing then is to define the actual mold base. So we have many different standards that we support. In this case we're using a Hasco standard, and we want to size the mold base. Solid Edge will give you an option to start with, but we actually need to make the mold base quite a bit longer because we have to incorporate that slide mechanism. The next thing we're going to do is define the standard plate thicknesses. So I made it 77 millimeters because I know the standard plate thickness is 76, and I want it to poke out through the parting surface by 1 millimeter. Now on the bottom side we're actually going to have blind pockets, so we're going to make that a little bit thicker. We need the blind pockets so that we can again have an area to mount our slide mechanism. So we preview that. You see it's going to add the entire mold base with our core cavity sets already built into the mold and the holes cut for those core cavity sets. The other thing I want to do is automatically add all the standard components that come with this mold, including the leader pins and bushings and bolts that hold this thing together. So each mold base comes with a standard set of components, and at this point we'll just add those in. So here we have all the mold components, and the next thing that we probably want to do is start defining through configurations the top of the mold and the bottom of the mold, or the injection side and the ejection side of the mold. And so we can just do that by just fence selecting half of the mold, and we're just going to hide this top half of the mold, because the first thing we're going to do is the ejection side. See, I still have my cavity blocks on the top of the mold, in my leader pins. I don't want to show those. I also don't really want the plastic part as being part of the ejection side configuration, so I'm going to hide the plastic parts. And at that point, then you can save the configuration. And when you save that configuration, I already have those configuration names in there. So you're basically just going to select it and update so it has the latest version. So we want to do the same thing for the top half of the mold. So I'll hide the bottom section here. Again, we'll just do that by fence selecting and right click and select hide. You won't get everything this way, but it gets the majority of the parts, and then you just have to hide the core blocks and the plastic parts again. Here I'm manually selecting them. You may or may not have noticed when I did this the last time. I select the part, and we have this option to find all identical parts in the mold and hide them all together. And again, I just need to update the existing configuration that's in this assembly already as the injection side of the mold. So the combination of the two, of course, is going to be all configuration. So you can actually select multiple configurations to turn on at the same time. We'll update that, and then again just reset the all configuration. We'll update that so it includes all the components, both injection and ejection side of the mold. So now I think we're ready to add our slide component, the slide mechanism that's going to drive that slide face in and out. As part of the setup, you saw the construction solids that were included in that subassembly, and that's what's going to be used to boolean away the material in those plates for that slide mechanism. So what I'm going to do here is I'm just showing the initial core cavity set, and this is what I'm going to use to place that slide mechanism. So in the slide folder, I'm just going to grab this metric slide components and drag and drop this into solid edge. And this is just normal assembly procedure where I'm going to mate the front of the slide face to the back, or the slide body to the back of the slide face, and the bottom to the bottom. And then this is where we're going to use that center plane that we created in the slide face to center up the slide mechanism. So you want to make sure reduce steps is turned off, and you're going to creating a planar alignment, and you want to select the slide body and turn on its reference planes, and you're aligning that again with the slide face, and if you turn on its reference planes, you'll be able to see that small center plane that we created when we built that slide face. If you wait for a quick pick, it will tell you the name of that plane. Again, center plane. And so we know that's the right one, and it just centers that slide body right up on that slide face. So now this is part of all of the core cavity sets. There's one needed for all 4 areas. And so what I want to do is actually transfer this subassembly into the parting zone that is patterned. So that will put one at all 4 locations automatically. It'll even tell us that that's what it's going to do. You accept that, and you can see it places them all. And now you need to tell SEMoldTooling that this is what we call a splitter object. And that splitter object, again, it'll take into consideration all of those construction solids in there to boolean away from the plates to create the holes for this mechanism. So we'll go to the splitter object. We just simply select any of the components. It will find them all in that subassembly. And we want to define this as cutting both sides of the mold. It's going to cut the injection and the ejection side with those construction solids. And when we accept that, of course, it's going to also make that happen at all 4 locations automatically because it's part of that pattern. So you can see that construction solid's been booleaned away from the core plate. I want to hide the heel block and the cam pin because those are on the injection side of the mold, so I'll hide those so that I can resave my ejection side configuration with all of these new components. I want to add those components to the injection side. So if I'll change my configuration to the injection side, and then I'll have to turn those components on and resave it here. So let's do that. On the injection side, you can see the pockets. I have the hole for the cam pin and the pocket for the heel block, and I'll turn those components back on. And I want to select the components and pattern those. So select those components, find all their identical parts, show them, and then again resave the configuration with these slide components as part of it. We'll go back to our ejection side.